Hi guys, before I go through the pack page on this, I'm just going to give a brief introduction to factorising quadratics when the number in front of the x squared is not 1. Remember, if it is 1, it just probably won't be shown because we don't show things, coefficients where they are 1 in algebra. It's a lot harder, or it seems a lot harder than factorising when it is 1, and I'll show you why that is. Okay, so let's have a look at why we do what we do so far when it is 1. Okay, because we probably haven't thought about that too much. Using FOIL to expand this, I'm going to expand before refactorising. So first times first would give me x squared. And I'm using an identity sign here because this will always be true. Outer ones would give me qx. I've gone for p and q here rather than a and b or anything, so I don't get mixed up with these letters up here. The inner ones, p times x would give me px, and the final two, the last two, would give me pq. And most of you know that when you expanded using FOIL, it's usually these inner two you can simplify because they are both coefficients of x, so both like terms. So we would add together the p and the q, and we would put that in front of an x. And our final number is usually just a constant, which is the product of those two numbers, p and q. Okay, I forgot to draw that in. So for example, if we had x squared plus 5x plus 4 that we were asked to factorise, that's why we always look for two numbers that have a product of 4. So I'm thinking of 1 and 4 or 2 and 2, and they have to have a sum of 5. So it's got to be this pair, 1 and 4, that go there. Okay, so that's factorising by inspection when the coefficient of x squared is 1. But if it's not 1, let's have a look at this as an example. I could have used another letter here just to be more general, but I thought I'd use a 2 here to show you what actually happens to this as we go. So first times first would give us 2x squared rather than just x squared. Outer ones would give me 2xq, or 2qx, doesn't really matter which way I write it. The inner ones would give me px, and the last two would give me pq. So notice that the pq is the same, the px is the same, but I don't have qx, I've got two lots of qx. I've got whatever that number is, lots of qx. Okay, and I also obviously have 2x squared. So when we simplify this, I've got 2x squared, and I've got 2q plus p in front of an x plus pq. So in other words, if I'm asked to factorise an equation such as, well, let's just think of one quickly. Oops. 2x squared plus 5x minus 3, hopefully that one works, then I know in one of my brackets I'm going to have a 2x, and the other one I'm going to have an x. And I know the two numbers in these brackets will times together to give me this number at the end, or in other words, minus 3. So my options are only 1 and minus 3, or minus 1 and 3, but they will not add together to give me 5. Okay, these numbers will not add together to give me 5. What will actually happen is that I need to double one of the numbers and add it to the other and somehow get 5. So how could I get 5 by doubling one of these numbers? Well, if I double the 3, that will give me 6, and add the other one, add the minus 1, that would then take it down to 5. So the one that I'm going to double would be this one over here in this bracket. So I need to put my plus 3 there, and my minus 1 there. We would never times a term by the other term in the same bracket. That's why it needs to go in the opposite bracket. Okay, so that's doing it by inspection, which is the method we're going to go through first. I've got two examples here to show you how it can sort of differ in difficulty even in this. Let's have a look at this first one. So I'm going to put my double bracket out ready. Now this is a nice easy-ish one because this number here is a prime number. So there's only one way that we can get 3x squared by multiplying the first two terms, and that's by multiplying 3x by x. Now, I need to times together these two numbers and get -2. Okay, so there's only one option there as well. Now, there might be a few options there on a harder question, but I can only times 1 and 2 together to get 2. Now, one of those numbers has to be negative, so it's either -1 and 2 or 1 and -2. And I need to, when I add them, I'm actually going to, this number here is going to get tripled because of the 3. It's not just going to be that number on its own, it's going to get tripled. So I'm going to triple one of these numbers, add the other, and somehow get -1. Okay, so let's have a little think. If I triple this, that'll give me -3. Add the other, that would take me up to -1. So that works straight away. So I'm going to triple -1, add +2. Okay, and there's my factorized expression, 3x plus 2, x minus 1. Okay, I'm going to go through another method with exactly the same examples below in a second. For this one, it's a bit more difficult because there are multiple ways of getting the 12x squared to begin with. We don't know whether our brackets are 12x at the start and x in the other one, or whether it's 6x and 2x that are the first terms in our brackets, or 4x and 3x. We don't know. That's why these are harder. But you can quickly rule out possibilities using this. It's a bit like a maths puzzle as well, these ones. So a lot of people like to use this method because it's a bit of a challenge to them. Anyway, what we do know is that our numbers in the brackets will multiply together to make -5. So we've only got one option, well, one pair, 5 and 1. It's either going to be -5 and 1 or 5 and -1. Okay, and I'm just looking at this one first, just quickly. I think we can rule this one out very quickly because our numbers have to add together to make +17. And in this method, this number in the second bracket is going to get multiplied by 12. Now, how could I make 17? Could I do that by multiplying one of these numbers by 12? If I multiply this 1 by 12, I get 12, and I can add 5 to get 17, but I can't add -5. And certainly if I multiply the 5 by 12, that's going to give me 60 and get me nowhere near 17. So I can rule out this set of brackets already. Let's try the next ones. 6, so one of the numbers is going to get multiplied by 6, and also in this method, this number here is going to get multiplied by 2. So it's actually both sets of numbers that are going to be multiplied by and get bigger than they actually are. So if I multiply this number by 6, I get 6. There's no way I can add this to get 17. Similarly, multiplying this by 6 will give me 30. There's nothing I can do with 1 that will give me 17. Okay, well, not with the numbers I've got. So I can rule out that set of brackets as well. And the final set, I'm going to multiply one of the numbers by 4 and the other by 3. Now, if I multiply -5 by 4, that will give me -20. And then add on 3, that will give me -17. Now I want +17, so if I do it with the other numbers, if I multiply the +5 by 4, that will give me 20x, when we do that outer pair. And then the inner pair, if I have the -1 here, that will get multiplied by 3 to give me -3x, and together 20x, take away 3x, would give me the 17x that I need. Okay, so this is my factorized expression. I'll show you another method of doing that. It's possibly a little bit more complicated, but those of you who are very good at remembering a method, no matter how long, and just applying that method might prefer this. So just going back up actually to when we were just looking at brackets like these, we can see that we got px as our final term, and we can see that even if that number there was bigger than 1, we would still get, sorry, pq, we would still get pq as our product. But we didn't have just p plus q as the coefficient of x. So what we're going to do on these ones is rewrite this. Now, this number here is a. Okay, so in our general way of writing quadratic, the number in front of ax squared is sorry, the number in front of x squared is a, the number in front of x is b, and the number on its own is c. So if we write out what these are, the 3 is a, the b is -1, and c is -2. Now the first thing you need to write for this method is what AC is equal to. So in my case 3 times -2 gives me -6. Now we're looking for two numbers that will times together to give me -6. And the same two numbers have to add together to give me what B is, -1. Okay, so numbers that times together to make 6. 6 and 1, no way I can use those. 2 and 3, yes. So if I use 2 and -3, you can see that that would work. What we're then going to do is put those back into the expression. We're going to rewrite it. We're going to use the first term as it was, but instead of having -x in the middle, I'm going to have plus 2x minus 3x. So I'm going to use those numbers here, and then I'm just going to put the -2 from the original expression at the end again. Okay, so this is equivalent to the original expression. Now what we're going to do is consider it in parts and just look at each part of it, and we're going to factorize each half. Okay, so looking at this expression here, what's common to both terms? There's only x common in both of those. What do I times x by to get 3x squared? 3x, and I times it by 2 to get 2x. Okay, now we're going to do the same thing to this half. Now, something common to both of those is first of all a negative, and then there isn't anything else common to both of those, but I am actually going to put a 1, which we wouldn't normally do when factorising something like this, but I am going to in this case, and you'll see why in a minute. Now, I times -1 by 3x to get -3x, and I times -1 by 2 to get -2. And if you've done this correctly, you will always get the same expression in these brackets. Now, using the distributive law, we can now write this as a product of 3x plus 2, and that's being times by each of these things in front of that bracket, which we can put together in their own bracket. So the x comes down here, and the -1 goes next to it. Okay, so what we've kind of done there is factorised again, with 3x plus 2 being the common factor. And there we've ended up with our expression, 3x plus 2, x minus 1. And if you look at the method above, it should be the same. Yeah. Okay. Some people find this easier for these sorts of questions because it rules out, well, it doesn't, you don't have to rule out brackets and options and things. It's less of a sort of mathematical puzzle, more of a kind of process. So here, A is 12, B is 17, and C is -5. So I'm going to start by doing AC, and that gives me -60. So I'm looking for two numbers that times together to make -60, and the same two numbers must add together to give me B, so 17. Okay, so that's going to be 20 and -3. So I'm going to rewrite the original expression as 12x squared plus 20x minus 3x minus 5. Okay, and a lot of you at this point might be thinking, well, does it matter which way around these two terms go? And the answer is no, it doesn't at all. Okay, I'll show you that it doesn't in a moment. Right, now we're going to consider it in parts. I'm going to factorise this expression, and what's common to both of those? There's 4x common in both, and we multiply that by 3x to get 12x squared plus 5, and that would be it. Okay, and when we factorise this part, again there's a negative common to both of those, and it's just 1 is my highest common factor, those two numbers, and I would multiply that by 3x plus 5 to give me that expression. And I've done it right because I've got the same thing in both brackets, and now I'm just going to combine the other two into their own bracket, the 4x and the minus 1. So this is equal to 3x plus 5 brackets 4x minus 1. Okay, which if we check the one where we did it before using the other method, 4x minus 1, 3x plus 5. Okay, it doesn't matter which way around those brackets come. So just to show you that it didn't matter whether we wrote the plus 20x or the minus 3x first, let me show you it the other way around. So consider it in parts again. What's common to both of these terms? 3x this time, and we would times that by 4x minus 1. Okay, and what's common to both of these terms? 5, and I would times that by 4x, and a minus 1 to get minus 5. And you can see that this time we've just got the 4x minus 1 in both brackets. It's just that we get the other bracket ready-made. That's the only difference. And in the final bracket will be my 3x from here and my plus 5. Okay. So very good method. It's not very intuitive though. It's not something that automatically jumps to mind to have to remember these things. So if you're just good at remembering methods, this might be the one for you. If you like sort of brain puzzles and doing it by inspection, then this one could be quicker. Okay.